Hello, welcome to e-CBSE online classes. In this video, we will be covering pair of linear equations in two variables for class 10th. The topic is why pair of linear equations. It is part B video in the series. In the previous video, we learnt about linear equations in two variables and said that generic form of linear equation in two variables is ax plus by plus c equal to 0 or ax plus by equal to c, where x and y are variables and ABC are real numbers. We also discussed about some example cases. Perimeter of a rectangle of length x and width y is 20 units. That can be written as 2x plus 2y equal to 20. That also can be written as 2x plus 2y minus 20 equal to 0. We looked at another case where cost of 2 apples and 5 lemons is 40 rupees, which can be expressed as 2a plus 5l equal to 40. It can also be written as 2a plus 5l minus 40 equal to 0. We also looked at another case where sum of two numbers p and q is 10, which can be written as p plus q equal to 10. It is also written as p plus q minus 10 equal to 0. Now, let's ask this question: why pair of linear equations in two variables? To understand that, let's go back and look at the same one of the example problems. That is, sum of two numbers p and q is 10, which can be written as p plus q equal to 10. That also can be written as p plus q minus 10 equal to 0, right? If you tabulate some data that satisfies this equation, you get a table like this. This is some data. Please note that this is some data. Otherwise, you can have a infinitely big table which satisfies uh, the equation, given equation. When you plot this data, you get a figure like this. The red color line is showing the equation, that is p plus q minus 10 equal to 0. We can now say that p and q corresponding to any point on the line is a solution to p plus q minus 10 equal to 0. For example, if I take p equal to minus 2, then q is going to be 12 and it satisfies p plus q minus 10 equal to 0. If I take p equal to 5, then q is going to be 5. If I take p equal to 9, q is going to be 1. And if I take p equal to 10, q is going to be 0, like that. One can pick n number of possible combinations for p and q that satisfy p plus q minus 10 equal to 0. It says that only p plus q minus 10 equal to 0 equation is not sufficient and it does not point to a unique combination of p and q, right? Instead, or in addition to the given statement, sum of two numbers p and q is 10, if I have another statement like p and q are equal, which can be written as a linear equation in two variables, that is p minus q equal to 0. When you put these two equations together or the two statements together, you say that p is going to be 5 and q is going to be 5. So we are talking about a unique combination of p and q, that is 5 and 5, right? In the similar manner, if I say that p is greater than q by 2, it can be written as an equation like p minus q equal to 2. Then we are talking about another combination, that is 6 and 4. P is 6 and q equal to 4, right? So we are talking about a unique combination, that is 6 and 4 for p and q, right? Now what you can say is, along with p plus q minus 10 equal to 0, another linear equation in p and q is required to represent a unique combination of p and q. You agree with that, right? Now let's take a look at another case. For example, I say that perimeter of a rectangle is 20 units, which can be written as 2x plus 2y equal to 20. That can also be written as 2x plus 2y minus 20 equal to 0, right? If you observe, the rectangle in green color satisfies the equation. The x and y corresponding to that rectangle is 1 and 9. The rectangle in red is also going to satisfy, for which x is going to be 2 and y is going to be 8. Similarly, rectangle in dark green corresponding to x equal to 4 and y equal to 6, and rectangle in blue corresponding to x comma y equal to 6 comma 4, and rectangle in pink corresponding to x comma y equal to 9 comma 1. All these rectangles are going to satisfy the equation. One can draw many more rectangles like that which satisfy the equation 2x plus 2y minus 20 equal to 0. Now we can say that 2x plus 2y minus 20 equal to 0 alone cannot refer to a specific rectangle. If you observe, it is referring to a family of rectangles. Please note this. It cannot refer to a specific rectangle. To represent a specific rectangle, we need to do something extra. For example, if I say that x is larger than y by 2, then I am saying that x minus y equal to 2. When I put these two things together, I am talking about a rectangle which has got x equal to 6 and y equal to 4. I am denoting that using a dark blue line. You see that rectangle I am talking about. For example, if I say that x is larger than y by 8, then what I'm saying is x minus y is equal to 8. It means I'm talking about a rectangle which has got x equal to 9 and y equal to 1. It means I'm talking about the rectangle in pink which is marked using red color line now, right? What you understood now is another linear equation in x and y along with 2x plus 2y minus 20 is required to specify a rectangle, right? If you summarize what we have learned, we can say that when a linear equation contains two variables, we also need another linear equation in the same variables to obtain a solution. You agree with me, right? This can also be said in other words as when two variables are involved, a pair of linear equations are required to obtain a solution. You agree with me, right? For example, you are given a statement like price of 2 apples and 5 lemons is 20 rupees. That can be expressed as 2a plus 5b equal to 20. This alone cannot give you any idea about price of apple and lemon. Whereas when you have another equation that says that price of 4 apples and 2 lemons is 24 rupees, that can be represented as 4a plus 2b equal to 24. You are talking about a specific price per apple and a specific price per lemon. We can express the pair of linear equations in two variables in a generic form as given here, that is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. When you have these two equations together, they are making some sense, right? These equations are also called system of linear equations. Please take a note of this. Now I have a question. What happens when three variables present in a linear equation? For example, if I have an equation like 2x plus 5y plus 5z equal to 100, what happens to this equation? The answer is fairly simple. One needs to have three such equations to obtain solution. For example, if you are given price of 2 apples, 5 lemons and 5 bananas is 25 rupees, that can be represented as 2a plus 5b plus 5c equal to 25. Price of 4 apples, 2 lemons and 6 bananas is 30 rupees. And you are given another statement, price of 1 apple, 1 lemon and 3 bananas is 10 rupees. Then when you write the corresponding equations and solve these three simultaneous linear equations, which are called system of linear equations also, to obtain prices of apple, lemon and banana. If you have only two equations, then you are not talking specific prices for apple, banana, and lemon, or one equation for that matter. You need, since you have three variables, you need three equations. Please take a note of that. In this video and in this chapter, we are talking about pair of linear equations in two variables. But in the field of engineering and sciences, one would be solving a system of linear equations containing thousands of variables and those many equations to solve a problem of real world kind. I- please take a note of that. I hope you like the video. Please subscribe to our channel e-CBSE online classes on YouTube and follow us on Facebook. Thank you.